And we are live. I'm playing a track called Unified Theory 3 because we're going to end up with one of these days. Unified Theory of Physics, that is. We are doing an abridged space weather edition today because we have to do a second live stream due to the results from the Event Horizon telescope to be presented in 6 press conferences around the world today. Allegedly, the first photographs of the event horizon of the galactic core of the Milky Way galaxy, Sagittarius A star. And we'll be very interested in that, as I don't believe in black holes. And the idea of taking a photograph of one, something that does not allow light to escape, seems pretty ridiculous. As without photons, you got no photograph. So, we already have links in the description of this video here to eventhorizontelescope.org. And right on this link, the EHT News blog, you can find all the links to where the press conferences are located. So we've got Brussels, Denmark, Santiago, Shanghai, Taipei, and Washington, D.C. And there are all the links for you. Just click on the description and check below. So at 1300 UTC, it is going to happen simultaneously. So the Brussels conference is in English, and the DC conference is in English. And of course, the rest are, let's see, Lingby's in Danish, Santiago's in Spanish, Shanghai Mandarin, Tokyo in Japanese, and Taipei in Mandarin also. So again, in the description below this video, you will see the link to eventhorizontelescope.org, and that will include all of that information. Let's take a look at the sun now. Oopsie. I can't read the tabs, folks. Looks like we've got some filamentary activity there on the southeast limb. This is the last 48 hours, folks. Quite a lot of filamentary activity on the east, and a bit on the west also. Let's look at the magnetic lines. And they don't show up too well on the 304 angstrom view. And let me move my tabs around so they're in the right place. Let's do a custom view of 171 angstroms here. We're going to look at only today, April 10th, from 0 hour until 7:30. So about 8 hours, 7.5 hours there. This sunspot did gain in complexity a little bit. That's sunspot 2738. It did gain a little bit of complexity. We'll show you what we mean in one moment. So there's the most recent view in 171 angstroms. And let's look at colored magnetogram real quick, just to see the complexification of that sunspot. The trailing portion gained a little bit of strength overnight, increasing the risk of flares a little bit, but still not really too significant. Let's go to helioviewer.org for a quick second here and look at this from the stereo A view. Gives you a good Earth scale here on helioviewer.org. Check it out if you haven't done so yet. There's a sunspot from the other side. And for any of you new viewers out there, stereo A is actually located, just a minute. Stereo A is actually located right about here. And so that view is looking like this at the trailing edge of that sunspot. So while we're on this page, here are your planetary locations, and here's where they are in 1 week. Bring up the real-time solar wind here. Give that a minute to refresh. We see a very high BT. Let's see, the BT is all the way up at about 6.7, and the BZ is in the positive. A couple fleeting phi angle connections here to the sun, but no ongoing ones. Solar wind density has dropped down to 5.27 protons per cubic centimeter. Solar wind speed 433 kilometers per second. Here's the latest on the Gong 2. Let's see what's going on with that North Pole field. As yesterday we saw it vanish for a moment. Let's see if it's come back. There's the vanishing, and it did come back. So that all has to do with that sunspot and that plasma in the corona. And it's kind of facing right toward the Earth right now. Doesn't look like any coronal mass ejections have happened, though. Let's move on to more data. Hit refresh on this. And the 10.7 centimeter radial flux is still at 79. For you new viewers out there, 10.7 centimeter radial flux is a great proxy for sunspot number. And there's the kind of graph we have on this cycle. We are well above predicted values. As you can see, the 80 line, right near the 80 line there. So that's a good thing. We don't want an extremely deep solar minimum. It's not good for our health as a planet, or a species for that matter. So we're at spaceweathernews.com here. We see a couple B-class X-ray flares there. Nothing very extreme. And the magnetometer is even more spiked than it was yesterday. There's the magnetometer. So now we're not even seeing anything coming out of the GOES 14, and the GOES 15 still looks like it's broken. Let's ignore that data entirely besides that commentary. All right, so, so the KP index is at 4 here. We're in unsettled geomagnetic conditions for the last 6 hours, coming up off of a KP of 2. And the electron flux is showing this characteristic dip that we would see during a coronal hole wind stream. Although we are at high relativistic electron levels. Here are your surface, your charging hazards. We see some surface charging around the western hemisphere there, around the equator. F2 layer is looking quite normal, actually. And there's your aurora forecast, borealis and australis. And we see a dip in the relativistic electron fluence from yesterday, but still much higher levels than we've been seeing. Excuse me. And let's look at solarham.net to see the analysis of that sunspot. All right, it's been upgraded to a beta class. So we do see a bit of an increase here. We see a second field umbra forming. And it's right in this area here. Very small, but some additional ombre there. So it's been upgraded to a beta class. A more serious sunspot than it was yesterday. Bring out the magnetosphere movies here. We're just going to look at pressure. And there's your magnetohydrodynamic pressure. You may not see it on every channel. You probably won't see it on hardly any channels. This data, incidentally, is not requestable. So if you're not viewing it when it's coming out, you cannot ask University of Michigan to view their archive, although they appear to have an archive. Here are the geospace magnetic ground perturbations. First, the poles. Oh, you're going to load. You're going to load, don't you worry. All right, let's look at the global view first. Now, for you new viewers, delta B is changes in the Earth's B field, and the B field is the field that goes through a magnet. For instance, the sun's B field is also the interplanetary magnetic field. It's the planetary equatorial plane, the B field. We're looking at the changes in the Earth's B field. For those of you not aware, the Earth has two poles right now. There's a North Pole up here, and there's a North Pole up here, and the South Pole is migrating toward Western Australia. And that is your pole shift information. Let's see if we've loaded at the poles yet. And there's the situation at the poles, where the sun's current aligned plasma sheets meet the planet. I shouldn't say the plasma sheets, I should say the magnetohydrodynamic energy. And let's move on to cosmic rays. Not expecting to see any upticks in cosmic rays, although we did see a large one yesterday at Athens. Check it out. The largest cosmic ray spike in quite a while. Let's look at Abridged and Barentsburg. There's Abridged, there's Barentsburg. Nothing to really see there. Mexico City. No giant cosmic ray spike there. Athens got cosmic ray fluxed, apparently. Not a lot going on at Oulu. I can still pronounce it, folks, trust me. There's DOMC Antarctica, and there's DOMB Antarctica. So one monitor showing a cosmic ray spike there, and the rest not. Check out Space Weather Enthusiast dashboard. Look at the current Enlil predictions here. Oh man, I apologize. So we're looking at very low plasma density forecast and a continuing elevated velocity on the forecast. So they're calling for about 500 kilometers per second solar wind speed there. And is there anything else we need to see on Space Weather Enthusiast dashboard? Let's just look at the visible light. You should be able to see that umbra forming, trailing sunspot 2738, making it a more complex group. See if we can see that. You should see a little bit of umbra form, and there it is. Kind of a second sunspot in the group there. and it is popping out around around 4 UTC. Oh wait. So it got upgraded to a beta class just a few hours ago, actually. So little beefier sunspot now. And let's move on to some more stuff here. Total electron content. Not expecting to see too many GPS errors here today, but let's take a look anyway. And just bear with me one moment, folks. I'm going to join the chat. Now, this is your total electron content. We'll look at 24 hours of earthquakes, and we saw some big ones, and it looks like some have just come in also. So we see a 4.4 at Japan, see a 5.0 at Colombia, 4.0 at Chile. I'm clicking it, nothing's happening. Hey, thanks. See a 4.8 at Taiwan, 4.0 in Afghanistan, 4.8 in Papua New Guinea at 167 kilometers depth. South Sandwich Islands, a lot of activity going on down there. We see a 6.8. Did it generate a tsunami? Looks like it didn't. And for that, we thank you. So that's the largest quake. We are still in a drought for magnitude 7 quakes. So if you're in these areas, please have a plep. That's too big of a dot there, folks. If you're in these areas, please have an earthquake plan, as magnitude 7 earthquake droughts typically end in magnitude 7 earthquakes. So those are the spots. All right, let's get rid of that. 4.4 in Montana. We'll have people freaking out that Yellowstone's going to erupt, but not I. Here's a 5.0 in Taiwan, 4.7 in Taiwan, 4.9 St. Helena, right on the plate boundary there in the mid-Atlantic ridge. 4.1 in Russia, 4.0 in Costa Rica, a 5.0 in New Caledonia, 5.0 in Indonesia. No tsunami generated from that either. Low pressure systems here. We're just going to show you what the pressure is over those areas that are prone to earthquakes. New viewers, low pressures are associated with earthquakes, folks. Believe it or not. It is true that insult can be added to injury if a thing like a hurricane shows up right after a deep earthquake shows up. It's not what you want to see. And we've got, well, let's let this forecast play here. I don't know why we're so far ahead. There we go. What's going on, windy.com? Anyway, we've had persistent lows in this area. And there's a very strong low right off of Japan. Bring that back again to get to current time. There we go. So a large, powerful low off of Japan there, and just south of the Bering Sea. We have an anticyclone off the coast of the US. And there's actually a very large low in the US. Might as well give you a radar view while I'm here. Here's your radar and lightning map as a value-added service. And if you're not familiar with lightningmaps.org, fantastic site. You can see where all the lightnings strike in the world in real time. A stray strike in the middle of the Pacific Ocean there. Check that out. Was it a sprite from space? We may never know. We'll skip AccuWeather for today. Look at volcanodiscovery.com. Give you a volcano rundown as quickly as possible. Maybe not as quickly as possible, but quickly. Shivaluch, back to eruptive behavior, producing a 33,000-foot plume. Volcanic uptick there. Kadivar, 4,000-foot plume there. Mount Ibu, 7,000-foot plume there. Bromo, 10,000-foot ash plume there. Dacono, 7,000-foot ash plume there. Revenador, 17,000-foot ash plume. And Sabancaya with a 28,000-foot ash plume. Volcanic uptick. Let's look at the Stereo A Core 2 Space Weather Beacon. Just rolls right off the tongue. We're going to max out the view. As this is the solar flare, coronal mass ejection watch section of the video. And it's playing extremely slow, so I'm just going to move it forward myself. Now, I would note one thing. There is a giant plume of plasma being held in place by that sunspot. Let's hope the whole thing doesn't suddenly release while it's facing the Earth. Although it is still pretty unlikely. Remember, a flare is not necessarily required. A flare is not required to produce a coronal mass ejection. We see plasma filaments ejected all the time with no solar flares. So don't confuse a flare and a coronal mass ejection. Solar flares are measured using X-ray, and coronal mass ejections are actual physical matter, not just electromagnetic radiation. Keeping it moving. And I don't know why we're on Extreme Tech. Let me get off of this. If you're on social media, check us out at minds.com/mashomash. Also, facebook.com/mashomash. We have started a nonprofit organization. Your donations will be tax deductible by the end of the year for that. Also, we're going to look at Null School real quick to show you some global wind patterns. Let's look at the poles. And there's a situation at the North Pole. And there's the South. And I don't know why that green circle's there. I have no idea what that is. So it is autumn in Antarctica right now. Let's get back to the event horizontelescope.org. Again, we have links to this in the description below. And we're going to be streaming when this happens at 1300 UTC. Let's play a clip from Sky Scholar channel. This video titled, "What are black holes? Science or science fiction?"
Many great men believe in God, but the existence of God cannot be tested as either true or false.
We're talking about doing science here, and whether or not black holes are a testable phenomenon in our universe.
The pantheon of astrophysics is headed by black holes. There is no observation that I could devise that would make an astronomer conclude that there are no black holes. If an object moves around a point that can't be seen, then there must be a black hole. Or if there is a bright object that pulls nearby a star, then also there must be a black hole.
In other words, what we're talking about here is a lack of tools in the astrophysical toolbox. The problem with astrophysics is that it's believed that gravity governs the entire universe. So let's just leave it there. Highly suggest you watch the video at Sky Scholar. Now let me bring out the chat real quick before I close out this video, because we cannot hang around. There's a lot of stuff to do, and we got to get out of here. So let me just bring out the chat. If you bear with me one moment, I will be right there. Welcome, Lisomthing. Welcome, Gagan Deep. Sansi Baton, Yannick Emmanuel Olet, Terrence Mooney. Cheers. We're going to bring up another custom view of the sun here, and then we're going to read your comments, and we're going to close this thing out. I'm trying to make this as short as possible. We got 15 more minutes of data. Let's look at 193 angstroms. Oh, that's odd. Okay. There was one error. Let's just refresh that. I don't know what it's talking about. That error was on your end, SDO. All right, we're up to 8 o'clock now. 193 angstroms view, please. And we have a winner. All right, so a couple things to note here. Let me pull this up to full screen. And before I do that, I would note that there are some insane bikes out there, and this is one of them. It even has the Zip 454 wheel set, which is an incredible wheel set, one of the most aerodynamic wheel sets ever. It's got the 454 on the front and the 858 on the back. It's probably too much bike for you. It's probably even too much bike for me, as this thing costs $16,000 before tax. All right, so back to the sun. If you're interested in stuff like that, head to veloshop.net, theveloshop.net, the official bike shop of the Lehigh Valley Velodrome. So here's 193 angstroms view. And I would note one thing, and this is also good news, the shrinkage of the North Pole coronal hole. Now, you look at the South Pole coronal hole, it's pretty big. North Pole coronal hole has been filling in for a couple months now. And that is a sign of coming off of solar minimum. And for that, we thank you. Yes, Liso, this is the legit live stream. I will show the image of the black hole, although the definition of black hole prevents me from showing an image of it, as to have an image, you need to have photons. And since black holes allegedly pull photons into them and don't let them escape, it would be pretty hard to photograph something that doesn't emit photons. Yes, there are some crazy blizzards going on, and that's a good point. I'm going to show the system associated with it real quick. Thank you, smAsho staff. You are doing a hell of a job. Yes, there is one hell of a blizzard going on. Let me show you the NASA GOES water vapor satellite map. go. And that's not the right view. All right, here we go. We're not going to get too into the weather on this, but we'll show you the water vapor, at least so you have an idea what's going on in the upper atmosphere. So there's your view of that. We see a lot of moisture and a very powerful low over the central US. And it's being compressed by this dry air. This dry air right here is acting as a barrier. And that's going to cause it to compress. The jet stream is going to curve back down like this. And yeah, the main compression is going to happen around these areas. So that's your water vapor map. And if you got any questions, concerns, comments, etc., please cover them now, because I can't control my own computer. The solar pole fields have not yet flipped. Although we are watching the North Pole field, it is gaining in intensity, and that's a good thing. And if I could just get back to the SDO image, there we go, back to 193 angstroms. We'd like to thank you for viewing, folks. Thanks, subscribers. Keep an eye on us. Keep an eye on the TV at 1300 UTC when those press conferences happen. I'm still deciding if I want to watch DC or Brussels. So join us. We're going to try to stream it and watch it at the same time. And I don't know, I'll closed caption it and try to talk over it so I don't get banned from YouTube. How about that? So thanks again, folks. We are out of here. We'll be back later. And remember, when you're staring at the sun, don't drink. And if you drink, stare at the sun anyway. Just don't drive. And since it'll never be now again, may the solar wind be at your back and the atherosclerosis absent from your arteries.